In this video, we're going to be talking about acids and bases, and we're going to be conducting an experiment to differentiate between the two. So acids have a low pH value, and if you don't know what pH is, we're going to get to that in a second. So acids have a low pH value, but bases have a high pH value. Acids, when they're mixed into water and create an aqueous solution, release hydrogen ions. These hydrogen ions are basically just a bunch of protons that end up swirling around in the water. Or in the aqueous solution. And similar for the base, except this time it doesn't produce hydrogen ions. Instead, it creates hydroxide ions. These hydroxide ions are produced in the aqueous solution, causing the substance to be basic, or what we call alkalinic. So now let's move on to how you can determine the acidity level or how basic it is. So there are three different ways you could test. One is through the litmus paper. Let's say this substance over here was acidic. If you were to put the litmus paper and make it have contact with the substance, then that would turn red. But if it was basic, it would turn blue. Similar for the pH level, when looking at the pH levels over here, when you dip the pH strip into the substance, what happens is that it creates a simple code of colors, and you can compare that code of colors to a cheat sheet that it has next to it. This will tell you how acidic or how basic it is, or how alkalinic it is. And lastly, we have a cabbage indicator. This cabbage indicator, which is basically just purple cabbage or red cabbage. Cabbage indicator is more homemade, that you're gonna add a solvent to that solution. So for example, let's take vinegar as our solvent, and when we add vinegar to this solution, based on the color of the outcome, it would tell you whether it's acidic or basic. So if it's between orange or red, then that would be acidic. But if it's between like blue or purple, that would be it's more basic. So in this situation, we know vinegar is acidic. Okay. Unfortunately, we do not have the litmus paper right now, but we will be testing the other two, which is the pH strip and the cabbage indicator. So let's begin our experiment. So let's create a cabbage indicator solution. So to create this cabbage indicator solution, we actually got it store-bought. So basically, we're going to be pouring this into the water, and that will create a solution. Now I'm going to pour the entire thing in. Okay, so as you can see, it has immediately turned purple. I'm going to shake it so that all the powder will get mixed in. And now we have this solution. We pour it into these glasses. We're going to be adding different solutes into it. So for one glass, we're going to be pouring vinegar, but the other glass, we're going to be pouring hydrogen peroxide, and so on and so forth, like Alka-Seltzer. So yeah, so on and so forth. So we can test how acidic or basic it is, okay? And also, at the end, we're going to be using pH strips to see how accurate we were. So I prepped everything that we need to do. So I have the baking soda, citric acid, vinegar, hydrogen peroxide. I even put the Colgate, or like the toothpaste. I put the soap over here, and we have the Alka-Seltzer anywhere. And now we're going to be putting in each of these little glasses to see how they react. In these glasses, we have these cabbage indicators, which is just another way to test if it's acidic or basic. So let's start. This one over here is citric acid. Alright, so one thing I have to tell you is that if it turns red, that means it's acidic, but if it turns blue, that means it's basic. And on what level of red or blue it turns into determines on how acidic or basic it is. So if it's a strong acidic, it would be really red like this, but if it's a very weak acidic, like pH level 5 or 6, then it would be more maroon kind of, a little bit more shade of purple than this. And same thing applies to the basic, except it's blue color. Alright. And now we're going to be doing vinegar. I'm gonna have to do a little bit. So you can see it reacted immediately. This is hydrogen peroxide. It turned more purple, which must mean that it's a very weak. Next, baking soda. Baking soda just turned black, which must mean it created like a neutral substance or something like that. And then here we're going to apply the soap. Lastly, we're going to put the Alka-Seltzer. Guys, let's just see the Alka-Seltzer did not exactly work out as planned, but it's fine. So it released carbon dioxide, showing the chemical reaction, and also all these it like changed color instantly, showing a immediate chemical reaction over this. You can also see that if it turned blue or purple, it's a base, but red or orange, it's more like a acid. So like or acidic. So now we're going to be comparing it. So we're going to be using the pH strip to compare it, which is just another way to test. Let's first start off with the citric acid or citric powder. All right, so this is what we get. So we're going to be testing it over here. If you look at it, it matches 1, which means citric acid is a very acidic one. So now we're going to be testing it another one. This is the vinegar. The vinegar matches more descriptions of like 2 or 3. I think mainly 3 rather than 2. So like, now let's do a hydrogen peroxide. If we look at hydrogen peroxide, try to match it with something. It matches more with 5s, meaning it's just regular acidic. Now that we wrote the pH, we're gonna move on to the next one. So we have baking soda powder over here. All right, I think this one actually matches like a 9 or an 8, mainly like a 9. So I'm gonna put this one under 9. So it's alkaline. Let's look at this next one over here, shampoo. And then lastly, we'll do Alka-Seltzer. So we just took a bunch of different solutes and we mixed it into the solution or dissolvent. And what happened was that it created a new solution, and this solution had a different effect based on the solute that was used. And we could see the difference based on the colors over here. The colors basically represent the difference between each solute based on one unison solvent. This is all about acids and bases.